Good morning, geometry students, and welcome back to week 2 of online learning on geometry. I hope you had a great weekend and everything went well. Remember to contact your teacher if it's not going well. We don't want you to get behind. Every week we're going to be recording grades and we don't want you to get behind. This week I am going to put in 2 videos, one video for just the notes and then a second video that will be for the reteaches because it was really hard to manage the papers with the reteaches. Uh-oh, here comes my pet again. What do you want this time? He wants to know if we're going to have a joke this week. Okay, we can have a joke. So we are going to be starting our study on solids. So how about this one? What solid can cure a strep throat? What solid can cure strep throat? Well, let's see by the end of the lesson if you will know what solid can cure strep throat. Let's get started. Chapter 11 is what we're going to be doing this week, and we're going to be looking at 11.1 and 11.2 for the homework, which again will come from the textbook and the reteaches. Remember, that's going to be a separate video. So our chapter 11 is on spatial reasoning, which is really just 3-dimensional shapes. So not too much different. You probably have had a lot of these shapes. 11.1 is on just looking at all the solids and seeing if we can name the solids. So we're going to have basically 4 different families of solids. We're going to have prisms, okay, which prisms would be like a box. A box of Kleenex would be a prism. So if you just got your brand new pair of shoes in the mail there, and they would be a prism in that box. We also have cylinders, and that would be like your can of corn in your cupboard. That would be a cylinder. And we have pyramids. Pyramids, you see, only have 1 point, so they're a little bit different and easier to see. And the pyramids, a lot of people just think of the pyramids from Egypt, which would be a good picture. It would be exactly what a pyramid is. And a cone, I hope everybody can go get one of these. That would be like an ice cream cone. And we name these different solids because of their bases. So the bases are the 2 congruent sides in the solid. So if it's a prism or a cylinder, you would have 2 circles, or you'd have 2 rectangles, 2 squares. But for pyramids and cones, they only have 1 base. Okay, notice it's not just the bottom because it could be the top, and of course we could even flip the cylinder around. But it is, you need to understand to look at the bases because that's how we name all of these solids. So our last thing on this sheet, the solids are named by looking at the shapes of the solids. So you want to look at the base, and that's how you can determine the name of the solid. So let's take a look at a few of these. Let's take a look at our can of corn grown up really big. Here would be our solid that's called a cylinder. It's a cylinder because it has 2 congruent circles on either side. So that would make it a cylinder. What do you think this shape would be called? Well, you're right, it has 2 congruent polygons. Those would be hexagons. So it would be a prism. So here's an example of a prism. Here's an example of a cylinder. Set those aside. Now, would this one be a prism? Obviously not, because it only has 1 base. The other side is just a point. So this would be an example of what we call our pyramid. Okay? And you're more used to these kinds of pyramids, and that's why we say they name these shapes by their bases, because this would be a triangular pyramid, or this one would be a square pyramid. If you had one with a hexagon on the base, it would be called a hexagonal pyramid. So they're always just named by their bases. So here we have 2 congruent sides. So is it a base, or excuse me, is it a pyramid or a prism? Well, it would be a prism. And it would be a triangular prism because it has triangle sides on both bases. When you turn it, you may say, well, yeah, but now the base is a rectangle. No, because remember it has to have 2 congruent sides, so it would still have to be these 2, okay? So that's how you name them. Oh, and of course we have our cone, okay, which I think is probably the easiest. And I don't have the whole sphere because it broke down in half because it rolled off, but this would be half the sphere, so you're just looking at it as a ball. We'll get into that one later, so I didn't put that one up there yet. Okay, those are basically our solids. And what we want to look at today then is just a lot of vocabulary with these solids. So go ahead in your notes there and let's take a look at a few vocab words here for our solids. So the first thing we have are faces. The faces are the polygons themselves. So if I just look at faces, I could say, for example, that this prism had a face of a triangle on the base, a face of a triangle on this base, and then it has lateral faces of rectangles. So lateral faces would be when you put the base on the table or on your desk, the shapes that are here, those are called lateral faces. And the bases are the ones that have to be congruent. So if I put this out, I could say this is a rectangular prism because it has bases that are rectangles, and then of course the lateral faces would be rectangles. So in this case, it wouldn't matter if you said it like this. It would still have two congruent rectangular bases, and it would still have the lateral faces as rectangles. So you've got face as the big idea of all of the polygons together. The lateral faces are just taking off the bases. So I could look at my cylinder and say I have two bases, and the lateral face is just this part in the middle, okay? Just this part, that would be the lateral faces. Hey, what about edges? Well, edges are just the segments. So just this segment. So if I labeled this rectangle as ABCD, I would have AB as one edge, BC as one edge, etc. Go all the way around. So you can see then you could count the number of edges. There would be 4 on the top of this rectangular prism. There would be 4 on the bottom of this rectangular prism, and then there'd be 4 connecting them. So this one would have 12 edges. And then the vertices, those are just the points. It's just like where the edges come together. So that point is a vertex, this point is a vertex, etc. So you really have a lot of just different vocabulary here, but it's not too difficult at all. If we move back to our pyramid here, and we say, okay, what are the bases of the pyramid? Well, it's only going to have one base. That would be this square. You can call it ABCD or whatever you want. And would have 4 triangular faces. Those are lateral faces because they don't include the base. They would have total of 5 faces. So we got the difference between faces, lateral faces, and bases. It's like these two go together and they're all called faces. Okay, just a couple of other ones here. Let me just read them and then I'll put this aside. A net is just like taking one of these shapes and cutting it so that it's all flat. Okay, but it does still have to be connected polygons, but it's just flat. And our last vocab word, a cross section. Looks like it's hard to put on there. A cross section, you're just going to take any one of these solids and cut it with a plane. Remember, a plane is a flat sheet of paper. So go ahead and stop the video if you need to get the rest of those in. But let me make sure that we understand that. So cross section, if I just said, okay, I want to make a cross section here, I would just say it would still make a hexagon as a cross section. Cross sections are very important though. I could do a cross section, let's say, of a cone. So if I cut it just straight across like this, parallel to the base, the cross section obviously would just be a circle. But I could cut it or cross it with a plane coming in at a slant. So if I slanted it, if you can see that or not, it's no longer circular, it would be an ellipse. What other cross sections could I do in a cone? Well, one of the important ones is one we studied a lot in earlier. It would be the cross section right through the top of the cone, and that cross section would make what shape? Going all the way through, you're exactly right. It's just going to be a triangle. You see what we're talking about with the triangle right down the middle there. So cross sections, you'll be able to see they're just the shapes that are made from those different planes intersecting here. Okay, now one of the most important things that we need to do in this section then is to be able to draw certain shapes. So the first one we want to be able to draw is a cube. Okay, so let's practice this together. To draw a cube, you simply make a square. So put a square on your paper, and then right in the middle of your square, start a second congruent square. Now you can do this for any prism, but this is one I want you to be able to make. And then you simply connect the vertices, and you now have a square. Now you can doctor it up a bit to kind of make it look three-dimensional. So remember, in three-dimensional, any of the dotted lines are recessed or pushed back into the paper. Okay, so we look at that now. We can say, okay, now how many of these faces would there be? So if you count the faces, now remember the faces count top and bottom and all the sides. So you'd have 1, 2, the two bases of the top and bottom, and then 3, 4, 5, 6, you'd have from the lateral faces, because 4 more to make the lateral faces. So I'd end up with 6 faces, okay? So that would be, you can see it in this one a little bit better, the top and the bottom, and then the 4 that are coming, the 4 squares coming down to it. So we have faces of 6. What about the vertices? So if I look at the vertices, those are just the corner points. Can you figure out how many vertices I'd have? So those would just be my points. You're exactly right. There would be 8 vertices. Now let's take a look at edges. How many edges would I have? Yep, edges are just the segments. So I just count the segments. There would be 4 on the bottom, 4 on the top, and then the 4 we talked about before that connect them. So there would be 12 edges. So somebody a long, long time ago decided, you know, I think there's a relationship between there. So he looked at this and he added the edges and the faces and the vertices together. And he said, hey, look, it's almost the same. And what he ended up with then is saying, hey, there is a formula. This guy's name is Euler. So it's called Euler's formula. And all it says is if you take faces plus the number of vertices in any polygon that's a solid, any polyhedron that's called, then it's going to make the edges as long as I add 2 more to it. So if I take the edges 12 and I add 2 to it, that would make 14. So I'd have 14 equals 14. So you don't really have to memorize this formula, and it is kind of a neat little formula that somebody decided that it really always works. Okay, so we're ending up just with a lot of vocab in section 1. The big thing in section 1 is nets. So I'm going to talk a little bit more about these nets. Nets can be made by taking any solid and cutting them apart. So if I take my prisms, and that can be just like a cereal box that you have in your cupboard. So let's take a look at these 2 cereal boxes. Obviously they are prisms because they have rectangular top and bottom, and they have 4 rectangular sides. My edges would be the segments that are making them, so it would have 4 on the top, 4 on the bottom, and 4 connecting. So I'd end up with 12 edges. To make the net, I simply have to just flatten this sheet out, and you can flatten it however you want. And that's the point, the last point I want to make here, is I could flatten it so that I have 1, 2, 3, 4, 5, 6 faces. This one's a separate face down here, or I guess it's up here. So I'd still have 1, 2, 3, 4, 5 is this face, 6 is this face. Kind of hard to tell on that. But you don't have to make it the same. So that's the point I want to make here at the end of this, is saying, hey, look, you could cut it out long ways. I still have 1, 2, 3, 4, 5, 6 faces. Exactly the same, but the nets aren't the same. So you really just have to visualize it and kind of put it back together to see if the nets are going to be mated. Okay, let's move on to 11.2 because it's a very, very easy lesson. All we do in 11.2. 11.2 is just volume of prisms and cylinders. Oh, what do you want this time? I think he just likes to be held. Ooh, he just likes to have you look at him every once in a while. Oh, he's seeing something over there. I don't know what that is. We'll have to figure that out in a little bit. Oh, so volumes and cylinders, 11.2. Okay, so my volumes and my cylinders, remember those were my circles with the top and the bottom. And all we had to do is, and this is on your reference sheet, just volume equals base area times height. So essentially all I have to do is take the base area of the base and multiply it by the height. So if I were doing the area of, or the volume of any cylinder or any square, let's say the edge is 5, I would just say 5 by 5 is the base. So my base area would equal 25. I can write upside down. So that's my capital B. So my capital B is 25 units, and I put that down as my base, and then I just say how tall is it? Well, if it is a cube, it's going to be 5 tall as well. So I literally just do 25 times 5. So I get 125. Now here's where our first new thing is. These are now going to be in volume. So if that was in inches, it would be in cubic inches, because inches times inches times inches is cubic inches. You could say that as inches to the 3rd power. So all our volumes are going to be measured in cubic inches. Okay, so let's just try one example here. Find the volume of a cylinder if the radius is 11 inches and the height is 1 foot. There's the problem. Let's just erase this. We know the volume is going to be the base area times the height. What's the base in our cylinder? Well, what is congruent on the top and the bottom? You're exactly right. The bases are my 2 congruent circles, and what's left, if I spread it on out for my lateral area, is really a rectangle. So you really have a net of a cube as being a rectangle and 2 congruent circles. That is telling us that the 11 inches is my radius. So my radius is 11 inches. And now we have our first problem. This says 1 foot, but I have to have the same units when I look at base times height. So I'm going to change the 1 foot to 12 inches, and then I'm ready to just do my formula. I like to look at it and say, what is the base first? So my base, let's even do that first. Let's put that in a different color. My base is a circle. So how do you find the area of a circle? Well, my base is then pi r squared. My height is just how tall it is, but it has to be in inches, 12 inches. So essentially I'm doing exactly that. I'm saying my radius is 11. So I'm doing pi times 11 squared, and now my volume then would be 121 pi times 12. And that would be my volume. Now, if you want a rounded answer, which it asks for on the homework here tonight, just pick up your calculator and you would just type in 121 times pi times 12, and we get about 4,559 square inches. Let's put it over here. 4,559 square inches. And that would be in cubic inches, because I had to multiply inches by inches to get the radius squared, and then multiply that by inches to get that squared. Now we'll do many more examples of that after we do the reteach video. So I want to move on to one last thing you may see, and that is what happens if I don't have a straight up and down shape. What if it slants? Well, this is called Cavalieri's principle, and it's best shown by just looking at like a stack of coins. So if I take a stack of coins, you can see how that makes a cylinder, because it's the same circle on the top and the bottom, and it's still the same if you slant it. It doesn't matter. So it's still base area times height. That's Cavalieri's principle, our last thing, where it just says it doesn't matter if it's slanted or not. If I had any shape, it doesn't even have to be a cylinder. If I look at it slanted, I just use the height, okay, not necessarily this side. So I'd still take the area of the circle and I'd multiply it by the height. That's Cavalieri's principle. Okay, that's it for this week. I will be looking at giving you another lesson on the reteach for the videos for 12 or 11.1 and 11.2. And he says goodbye. Oh, and don't forget, think about what that answer is. Okay, see you next week.